Section 11.3, we're going to talk about parabolas. So the definition is the set of all points in a plane equidistant from a fixed point called the focus and a fixed line called the directrix. Now we also have this p-value, which we'll talk about when we draw these. It's the distance from the vertex to the focus and from the vertex to the directrix. The vertex is located between the focus and the directrix, and the focus is located within the parabola. So let's go ahead and just look at an animation that I have here. Now, let's say that right here, this line that's down here, this is going to be the directrix. Oops. Directrix, not with a C, X. And this is going to be the focus. So the, again, definition is the set of all points equidistant from a fixed point, which is the focus, and a fixed line, the directrix. So no matter, notice these lines that we have right here, that distance is always going to be equal. And so if I hit play here, you'll see that this is going to form the shape of our parabola. So notice when it moves, as long as the points are equidistant, they're going to keep on moving, and you're going to get the shape of your parabola. And if we go back down to right about there, the distance from here to here is always, again, going to be the same, because notice that the length from any point from your focus to the point in the parabola to the directrix is always going to be equidistant. And because of that, we know that this point is my vertex. So because this distance and this distance are always equal, we can use the midpoint formula and the distance formulas in order to figure out what the equation for the parabola is. Now, we'll talk about this value right here, which is a is equal to 1 over 4p in a little bit. But we have two kinds of parabolas. We have vertical parabola and horizontal parabola. So vertical parabolas are ones that open up or down. And remember that we also have parabolas that can open left and right. So that would be opening to the right. And then if I have a parabola going the other way, it opens to the left. So it just depends on what type of equation. Vertical parabolas are always going to be y equals equations. Horizontal parabolas are always x equal equations. So if you look down here, we have the actual equation. So y equals a times x minus h squared plus k, or notice this one is x equals a times y minus k squared plus h. So if a is greater than 0, we know that the parabola is going to open up for this equation. If it is greater than 0 for an x equals equation, it opens to the right. If a is less than 0, it's going to open down, and this one's going to open to the left. The vertex, even though we're changing our equation around, is always still going to be h comma k for these equations. And the focus is going to be this p-value that we're going to find using this equation right here. So the focus is going to be at h comma k plus p for parabolas that open up or down. And for parabolas that open left or right, you're going to change your x coordinate, so it's going to be h plus p comma k. Now, another thing to talk about is that your focus is always on the inside of your parabola. So when we look at some more pictures of these, that'll make some more sense. The directrix is going to be y equals k minus p, and x equals h minus p. The axis of symmetry for y equals equation is x equals h, because it's the line that cuts your parabola in half. So in this case, it would be an x equals, and this one's going to be y equals k. So it switches. Now, parabolas that open up or down, you're changing your y value to change for your focus, and parabolas open left or right, since it's x equals, you change the x values. Now, we also have what's called the lattice rectum, which is the absolute value of 1 over a. It tells you how wide the graph will be. And remember that the a value that we're getting is just from this right here. So notice that the three variables we have for our equation are a, h, and k. So that's what you always need to find in order to write the equation of these parabolas. So if I go over here, just to kind of look at these pictures, the first one is parabola that is opening upward. So this would have a positive a value. If it would open down, it would be a negative a value. So for this line right here that's dotted is the directrix. And of course, this is in the middle right here, the vertex, which is h and k, because we're saying this is at the center. The distance from here to here is always going to be the same. And the distance from the focus to the vertex, that is a distance of p. And then since these are equidistant, then this is also a distance of p right here. And that yellow line is the lattice rectum, which tells you how wide the graph is going to be. And you just find the lattice rectum by taking that a value from your equation, and you do 1 over a, and it's always the absolute value because it's a distance. So the same thing for parabolas that open left or right. So looking here, this distance is your distance of p. So this distance would also be p from, again, from the directrix to the vertex, and the vertex to the focus is always the same distance. Now again, just to look at your general equations, we have them right here. And so it's really important that you remember these equations. So we have p is equal to 1 over 4 times a, or we can also say a is equal to 1 over 4 times p. So you can interchange them. When we are graphing these, we're going to, if necessary, complete the square. We're going to determine the direction of the opening, find the vertex, hk, and then find the directrix. So notice that for equations that open up or down, the directrix is y equals, and for equations that open left or right, it's always going to be x equals for that. And notice, again, the focus is always on the inside of our parabola. So let's do some practice of this. Now, before I move on, I just want to say that some books and some people write these equations differently. I like to use the forms that we have right here because this is more of a vertex form. However, you'll see sometimes that people will write the equation like this. So they'll write 4p, and this would be y minus k equals x minus h squared. Sometimes people use this as a standard form. I think this equation right here is a little confusing. Basically, instead of using this equation that I just wrote, I like to use the equation that's up here because it makes it a lot easier because we're used to that kind of form. So if you solve this equation that people use, you end up with this formula. The only difference is you would first divide by 4p, so you get y minus k equals 1 over 4p. And then if you add the k to the other side, you get y equals 1 over 4p, which is, remember, your a value, times x minus h squared. So that's where, if you see anyone write this formula, it's just the same thing as what we're doing. We're just not writing in that form. We're using vertex form. Okay, so let's go ahead and start. I'm going to write my equations at the top because it helps me remember them. So y equals a times x minus h squared plus k. This is a parabola that opens up or down. And x equals a times y minus k squared plus h, again, parabola that opens right or left depending on the a value. And remember, a is equal to 1 over 4p. So looking at the first equation, I always look at the a value to tell me which direction I'm going to open based upon what's being squared. So I know the x is squared here, and it's a y equals equation, so it's nice that it's already solved for y for us. So that tells me that my equation is going to open down because my a value is less than 0. Now that I know my equation's opening down, I can find my vertex. My vertex, remember, is just h and k, so this is h and k, so it's opposite of what's on the inside being squared. So this would be vertex of -2, -3. The focus for this point we are going to use by using our a value. So a is equal to -1/4. So remember, we're going to use this formula right here. So -1/4 equals 1/4p. So then if we solve by cross multiplying, we would get -4p is equal to 4. So again, I'm just cross multiplied. And then we would get p is equal to -1. So we'll do that as we do our graph. So the next thing I would do is I would go ahead and graph the vertex. So I have -1, 2, and down 1, 2, 3. Since my parabola is opening downwards, I know the focus is always on the inside of the parabola, and it's in line with the vertex. So that means that I know, since it's a distance of -1, that means I'm going to go down 1. So this point right here is going to be the focus. And so I can actually write that point. So that would be at -2, and notice I changed my y value to -4. The directrix would go the other way. So for the directrix, we have a line that's going to be here. So that is my directrix. And now I just need to, so I need to write the equation for this. So the equation for the directrix, since it's a horizontal line, is going to be y equals, and we're taking the y value from our vertex and we're moving it up 1, so y equals -2. And then my axis of symmetry is always a line that cuts my parabola in half. So in this case, since my parabola opens up or down, it's going to be x equals the x-coordinate of the vertex, so x equals -2. And then the latus rectum, remember we said, was the absolute value of 1/a. So in this case, it's going to be the absolute value of 1/-1/4, which is just equal to 4. And so for the latus rectum, what you do is you're going to count from the focus to, and remember the distance, then that means it's going to be 4 from the points on each point on the parabola. So count from your focus half that distance. So if I count 1, 2 here and 1, 2 here, I know those 2 points would be on my parabola. Now, because this is a y equals equation, you could also graph it in your calculator and then get the points. That would be fine too. But now I know my graph is going to go like this. And again, notice that the distance from the directrix to the vertex is the same as the distance from the vertex to the focus. This distance right here was the latus rectum. So remember, if you do half of that, and then go to the right and the left of the focus, you will get that how wide your graph is going to be for that part. And then that is basically all that we need for our graph. So let's go ahead and do another practice one. And before I do another practice one, this line right here is the line that would cut my parabola in half. That's why we had our axis of symmetry at x equals -2. All right, so for the next one, we have an x equals equation. Because it's x equals, I know that my graph is going to open to the left or the right. I know in this case, because my a value is positive, my graph is going to open to the right. The vertex, remember, this is still h and this is k, because y always goes with k. So the vertex is 4, 2, so opposite of what's being squared. And a lot of students write that wrong, so be careful when you're writing those graphs so that you don't mess it up. So then I want to find my p-value so I can find where the focus and directrix is going to be. So I know a is equal to 1/16. So then a is equal to 1/4p. So I'm solving this. 1/16 equals 1/4p, cross multiply. 4p is equal to 16, divide by 4, so p is equal to 4. So that means from the vertex, which is at 4, 2, my graph is opening to the right, so I know it's going to be a distance of 4 from here to my focus, and then to the right, because it's always on the inside of your parabola. and because that value is positive. And then if I go to the left 4, that's going to give me my directrix, which is going to be right here, so on the y-axis. Now I can find this point. So if I just even count on my graph, I have the focus at 8, 2, and the directrix is at x equals 0. The axis of symmetry is going to be the line that cuts my parabola in half, so it would be the same on both sides, which is going to be now this line, which is different from parabolas that open up or down. So that's going to be now the y-coordinate of my vertex, so y equals 2. The latus rectum, remember, is going to be the absolute value of 1 over a. So in this case, we have the absolute value of 1 over 16, which is just equal to 16. So half of 16 is 8. So from my focus, I'm going to count up 8 and down 8. So here and here. So then from there, I can draw my parabola. And now I have my graph. Now for these parabolas that open left or right, you can also put these into your graphing calculator and get points, but first you would have to solve for y. So let's go ahead and practice that. All right, so I just copied this onto another page just so that we can practice taking this equation and graphing it with an x equals by solving for y. Okay, so the first thing I would want to do is get anything that doesn't have the y to the other side. And so that means because this is in parentheses here, I'm going to have to do that part last. So I have x minus 4 equals 1 over 16 times y minus 2 quantity squared. And then I want to get rid of the 1 over 16, so that means I'm going to multiply both sides by 16. And so I have 16 times x minus 4 equals y minus 2 quantity squared. And then to get rid of something that's squared, you have to take the square root. Don't forget the plus or minus. So I end up taking the square root of both sides. And so I have plus or minus the square root of 16 times x minus 4 equals y minus 2. And then the next step would be to just go ahead and add the 2 to the other side. And instead of putting it behind the radical, I'm going to put it in front, so that way there's no confusion as to it being underneath the radical, because sometimes people confuse that. So I'm going to write 2 plus or minus the square root of 16 times x minus 4. So in your calculator, you're going to have to plug this into y1 as 2 plus root 16 times x minus 4, and also y2 to minus root 16 times x minus 4, because remember, we don't have plus or minus in our calculator. So when you plug these in, then you could go ahead and check to see what it looks like, and which you would get a parabola that looks like ours. But of course, remember, we have to also know how to find the directrix and the focus, so we still have to do all this other work. Okay, so then let's go ahead and go to number 3. So for number 3, this is an x equals equation. Because the a value is negative, a is equal to negative 1/8, I know that my parabola is going to open to the left. And because it's opening to the left, I know that this is my k and this is my h. So we have negative 2 comma the opposite of what's being squared, so negative 3. And that's what I'm going to put on my graph first. So negative 2, negative 3, which would be here. Then I'm going to find the focus by using the fact that I know the equation to find that is a is equal to 1 over 4p. So in this case, I have negative 1/8 is equal to 1 over 4p. So cross multiply, and we get negative 4p is equal to 8. So then divide by negative 4, and p is going to be equal to -2. So that means that because my graph is being opening to the left, I'm going to go to the left 2 from this vertex, and that's because its p distance is -2. And then if I go to the right 2, I'm going to get my directrix. Remember, it's a vertical line because it never will go through your parabola. So now I have that. So again, remember this was just a distance of 2 because our p-value was 2. And now I need the right-sided points down here. So the focus point was at now -4, -3, and the directrix is at x equals 0 because it's a vertical line. The axis of symmetry is going to be cut in half this way. So since it's cut in half that way, it's going to be the y-coordinate of your vertex, which is -3, so it's a horizontal line, so y equals -3. And the lattice rectum will help us graph our parabola instead of having to, and like I said, you could still solve for y equals just like we did in the last one, and then graph in your calculator and plug in points for x and y and solve, but I find it easier just to find the lattice rectum distance. So for this we have, remember the absolute value of 1 over a is how you find that. So the absolute value of 1 over -1/8 gives me the distance. So that is equal to a value of 8. So half of that is 4. So from the focus, I'm going to count up 1, 2, 3, 4, and down 1, 2, 3, 4. And now I have my graph. And that's it. So bring this with you to class, and we're going to do some more practice.